makes me happy. So we're going to solve lots of different kinds of equations. These are called radical equations. Let's just go back to linear functions. How do you know something is linear? How do you know just by looking at the equation that it's linear? Like I told you both was linear, but how do you know that? No exponent other than 1. So we call that a degree of 1. So how do you recognize a radical equations? Well, equations are just like people. You recognize them by the characteristics that are unique to those people. So I might recognize Nicole because she has long brown hair, right? So when she comes in, she's little, she's tiny. I'm like, hey, that's Nicole because I recognize her. Even if I didn't see her face, I probably would be able to tell her from the back. Equations are the same way. You recognize them by characteristics. So linear, no degree higher than 1. Radical, how do you recognize something as radical? Oh, more obvious than that. It has a radical in it. That's how you know it's got a square root somewhere in the equation. That's what makes a radical equation radical equation. Step number 1, isolate the radical. Isolate the radical. Step number 2, square both sides. Square both sides. I'm going to make 2 little notes under step 2, and I'm going to use my red pen, which I guess is pink because I can't find my red one. First one I'm going to make is brackets, which I'll explain when we do an example.
Funny how like at first it looks red when you actually write.
No, it's like a magenta though.
But then after a second
Yeah, because I have a pinky pink one. I had a red one. Oh, there, it's at the bottom. Well, I can't switch now because I'm left-brained. The other one is 1 squared, so I'm just writing a little exponent of 2. 1 squared on each side. And I'll explain that when we get down to a later example. 1 squared on each side. Step number 3, isolate the variable. Isolate the variable. And step 4, which is the last step, I'm going to do in red pen because it's something a little bit different than what you haven't seen before. And I'm going to put a star next to it. And if I had glitter glue, like I'd put that on there, maybe some flashing lights.
Yeah, I remember you always telling us that.
Linear equations, which you've been doing for grade 8, grade 9, and grade 10, are not special. They are just kind of normal everyday equations because the graphs are just lined, they're kind of boring, there's nothing special. There's a group of equations that are called special equations, and you are meeting the first type today, which is called radical. You're going to meet 1 more type this year, 2 more types next year. They're called special equations. And they're called special equations because sometimes you do all the solving and you get out this answer, x equals 3, for example. And then when you plug it back into the equation, you'll find out it doesn't actually work. It's not actually an answer to the equation. That never happens with linear. Linear, when you get out an answer, if you plug it back in, it's going to work, providing you didn't make a mistake. Special equations are like little tricksters because they think that they have an answer, but then when you check it, it's not going to work. So the last step has to be check your answer. Check your answer by substituting into the original equation. Check your answer by substituting into the original equation. Check your answer by substituting into the original equation. Because sometimes it's not going to work out. So linear equations, right, we showed you in grade 8 how to check your work, and we're always like, you can check your answer, but you know, if you don't, who cares? This one you have to check, because if you don't check, you're not going to know if that answer actually works or not. So this isn't like a if you want to, like linear, this is a you have to do this last step. And I'll show you an example when we get to some of the harder ones, what's going to happen if you don't check. Okay, so first example we're going to do right on the paper so that we can number it the same way. Isolate the radical means I want this radical x all by itself, so I want that 3 out of there. How do I get rid of a coefficient of 3? So I'm going to divide each side by 3. And if I divide the other side by 3, what happens? 2. That's step number 1. Step number 2 is called square both sides. So go back in your head to grade 8. I want you to think about Pythagorean theorem. A squared plus b squared equals c squared. And you're finding the side of a right angle triangle, and you do all this work, and you get down to c squared equals 100, for example. And we were like, how do you get rid of a squared? What's the opposite of squaring something? And what do you do to c squared equals 100? You square root it. This is just going opposite way. This time we have a square root, so what's the opposite of square rooting? Squaring. You have to bracket both sides, and you have to put 1 on each side. So to balance that equation, you can't just put 1 on the left. You have to put 1 on the left, 1 on the right. What happens to the square root of x when we square it? And what happens to 2 squared when we check it?
4.
Isolate the variable. It's already done. X is all by itself already. Step number 4 is our checker. So I'm going to do this one in red just so it catches your eye. You go back to the original question, not step 2, not step 1. You go back to the beginning. We're going to take out x. We're going to put in 4. And what it means to check is you can't start moving stuff from side to side. You can't start dividing by things. What it means is you evaluate the left, you evaluate the right, and you're trying to see are the 2 sides exactly the same. You can't start flipping stuff from side to side. I'm going to do the square root first, so I'm going to leave the 3 and just evaluate. What is the square root of 4? 2. And then the multiplication, what's 3 times 2? So 6 equals 6. What does that tell me about x equals 4? It is the correct answer. And you're going to see later on, you're going to get examples where you might get x equals 4, but then you check it and the 2 sides aren't equal. And then you're like, what the heck? Where did 4 go? Oh, I'll show you that when we get down there. This never happened with linear equations. Ever, never, never. If you checked it and you got the right answer, it would always work. This time, that's not going to be true. They're called special equations, and this is the first type, which is radical. How are you feeling so far? The beauty of this is they're never going to change. It's the same 4 steps every single time, and there is no exceptions. If there's exceptions, I would tell you, these are the same 4 steps that's going to work you through every single one of these questions. That's why I love solving equations. Love it. Do you have your title down already? Like, you're doing real pre-cal math now. Like, this is smart people math. This is what, like, doctors and engineers do. Step number 1 is isolate the radical. So all of this needs to stay right now. I need to get rid of that 4, and I need to get rid of that minus 5. I'm going to start with the minus 5. What's the opposite of subtracting 5? So I'm going to add 5 to both sides. Now I want to get rid of the coefficient of 4. What's the opposite of multiplying by 4? Dividing by 4. That is step number 1. Isolate the radical. Get it all by itself. Step number 2, square both sides. You have to use brackets, and you have to put 1 on each side. What happens to the square root of x plus 1 when I square it? So the radical disappears, becomes x plus 1. And on the right-hand side, 2 squared is? Step number 3, isolate the variable. So I want this x all by itself. How do I get rid of a plus 1? X equals? If this was linear, we'd be done. We're like x equals 3, check, move on. But this is a special equation. So we don't actually know x equals 3 yet. What do we have to do? And I always do that on the right-hand side. I don't know why, my brain left, right? I can't do it on the bottom. I always do it up here. Come back to the main question, take out x, put in 3. I'm going to do underneath the square root first. So what is 3 plus 1? Next, I'm going to do the square root. What is the square root of 4? Next, I'm going to do the multiplication of 4 times 2. And then the subtraction, 8 minus 5. What does it mean 3 equals 3? It means that this is the correct answer and this is indeed a solution. I want you to go through this example, and I want you to number where you see the steps. So next to step 1, I want you to put a 1. Next to where you see step 2, put a 2. Next to step 3, put a 3. Jack, are you numbering? He has no idea what I'm talking about, but it's fun to watch him try to fake it. This is quite enjoyable, actually. Yeah, but we're all already doing something, but you weren't listening, so you don't know what we're doing. But it's kind of fun. So step 1 is somewhere in that section. This is where we did step 2, down to here. Step 3 was our isolating, and step 4 was this whole side. Same 4 steps every single time. They will not fail you. They will not let you down. It's the exact same order every single time.
Oh, I thought you were asking us to number example 3 before we do it.
No, 2, go back and number it. But now that you say that, let's do number 3.
Yeah, because I wouldn't be able to number this unless I actually did it first, probably. Actually, no, definitely.
What is step number 1? Well, what do we do when they're all over the place?
Move them to one side.
Yeah, this is just like if those roots weren't there and we had x's on both sides. What do we do when there's an x on both sides? We put them all onto one side, and anything that's not an x, we put on the other. So I'm going to start with this 2 root x, and I'm going to bring them to the left. And how do I get rid of a positive 2 root x? And then when I combine 3 root x with negative 2 root x, what do I have? Just root of x. And then I'm going to take the negative 4 and take him over, and what happens to him if he's negative now? He's positive. And on the right, I have that 1 plus 4, which gives me 5. That's step 1, isolate the radicals. So bring them all to one side and combine them. Step number 2. Square both sides, put brackets, and put 1 on each side. Square root of x squared. 5 squared. Step 3. Check is step 4. What's step 3? Isolate the variable. Done. Now we can go to step 4. Just repeating, you have to go back to the main question. You can't go up to step 3 or step 2 or step 1. You got to go back to what the question asked. I'm going to do the roots first on both sides. So this gives me 3 times 5 minus 4 and 2 times 5 plus 1. Then the multiplication, 15 minus 4, 10 plus 1. Then the subtraction, 11 equals. Conclusion,
It's correct.
25 is our answer. 90% of the time your answer is going to work. It's that little 10% of the time that it doesn't. And on the exam, we're going to put one that doesn't work to make sure that you're checking it. Heads up. I'll tell you, we're not there yet. I will tell you. I would never leave you hanging. It's too exciting. Show me your thumb. Are you getting this? Following the steps? Kind of following the steps? Not following the steps. It's good. Shh, don't spoil the fun for them. Because now they're going to peek at the box, and they're going to be like, what's that word? And then they're all going to freak out. And see? That was a spoiler. That was definitely a spoiler alert. That was a spoiler.
I don't like that word. It's too big.
What is step number 1? So the radical has to stay by itself. Everything else has got to go over. What do I do with that 3 that's hanging around in front? Minus them to the other side. That's going to make the right-hand side become? Step number 2. I just did a really, really common mistake that someone is going to do on the final exam when they're in exam panic and it's sweaty in the gym and people are starting to hand in the exam and you're not even ready and your mind goes blank and you have no idea what's going on. Someone is going to do this. Tell me what I did wrong. Yeah, did I balance my equation here? No, and what's going to happen is you're going to forget about the other side. So just make sure you're in the habit of squaring both sides. This leaves me negative 3x plus 1. And on the right, step number
Squaring it, wouldn't that make it 3x plus 1?
but all this square does is it just takes away this root.
Okay.
It doesn't touch anything underneath. The radicand stays the same. Good question.
Okay.
Step number 3, isolate the variable. What would you like to do with that 1? What would you like to do with the negative 3? X equals? Or does it?
We'll see. We will see.
That's a spoiler alert. Oop.
I said we will see.
No, not you. The boys at the back. Bicker corner back there. Spoilers. You're association now. You're just with them. You're like right in the middle of them.
That's the equivalent of me
Yeah.
plotting across.
Yeah, well, she picked the seat, I gotta say, you know.
Plotting across, but I
She
thought
picked
her fault
it.
gets hit by a bullet.
If you choose to stand in the bullet's path,
People shoot. I'm gonna stand here.
Maybe you're trying to get through and you don't know what the devil's going on.
oh, but she knows. She knows what's going on back there.
I'm trying my best to defend the camera. I swear to God.
Negative 3 times negative 5. Negative 3 times negative 5. And then plus 1, I'm going to do all in one step. Now we do the square root. What's the square root of 16? And 3 plus 4. Conclusion.
It works.
Happy face. Are you starting to see the same 4 steps every single time? Not going to change. They're not going to let you down. You just need to use them properly. No. There's just one little extra teeny tiny little step. Teeny tiny. Teeny tiny. You're probably going to enjoy it, actually. Patience was never my strong point. Look, I'll admit it, I'll own it. I was a Christmas present peeker. I will fully admit it. I used to peel the tape back and then peek and then put the tape back. Put it back. I know.
Never happened. Never happened.
I'm not a patient person. I can't wait.
I have a hard time with patients too on occasion. I have a hard time with patients too on occasion, but but for the most part, I understand when it's necessary, and I can maintain myself. Well, yeah.
Step number 1. Isolate the radical. This guy's got to stay. Everything else got to go. What do we do with that plus 5? Minus 5. Step number 2. This is why you need the brackets, because watch what's going to happen on the right if I don't bracket it. Well, yes, but... Yeah, is there a difference between negative 3 squared and negative 3 squared? Right, so this is why they have to have the brackets, or you may miss that it's negative 3 times negative 3. That's why I was like brackets, brackets, brackets. Radical's going to cancel, so it's going to leave me 2x minus 1. On the right, I've got negative 3 times negative 3, which gives me... 9. How do I get rid of the 1? How do I get rid of the 2? Step number 4. I'm going to do under the root first, so 2 times 5 minus 1. Square root of 9. Three plus 5. This is why we need step number 4, because 5 looks like it's a great answer. Looks like there's nothing wrong with it, but when you come over here, it falls apart. Here's what we do when the answer does not work. We cross it out. That shows me you understand it was 5, but now it can't be 5. Don't erase it, don't leave a blank. That shows me you don't know what you're doing. You just cross it off. This is called an extraneous root. What does extraneous mean? What's the first 5 letters of extraneous? Extra. It means not needed. If something's extraneous, you don't need it. It's just extra. So this is what's called a not needed root, and you'll find out in Unit 3 what a root is. An extraneous root is a solution that does not work when you check it. An extraneous root is a solution that does not work when you check it. You don't need to write down extraneous root. I just want you to hear that word because it's going to come back in next units and then next year as well. All special equations might have extraneous roots. That's what they're called. What do you do if you get an extraneous root? Just cross it out. That's it.
Nope, it can't be solved.
You just put a big X through it. Reese, isn't that kind of fun? Like you get to put a big X through the number? It's kind of satisfying. A little bit. Kind of satisfying. Last one.
Why is it not? Lazy. Really? That's pretty damn lazy. No, it kind of actually just it's surprisingly so.
Oh, I want to show you something before I wrote number 6. Is that going to upset you if I white it out? How about I show you something down here? I'm going to show you a wrong way to do number 6 or number 5, and then you'll see why I told you something earlier. So this is what I see all the time. Someone's going to do it because I see it every single year. It's usually on the exam when you're all panicky because it's like June and you just want to get out of there, and the gym smells because it's June and it's hot, and then your mind goes blank and you just start doing crazy things. Totally up to you. So I didn't do step 1. I went right through to step 2, which your brain is going to want you to do because you're going to see a radical, and in panic you're going to think square, square radical, squaring a radical. But what's the other huge math mistake that I made here? Besides isolating it, there's something else that I've done. How many squareds are on the left?
2.
How many squareds are on the right? Did I balance my equation? That's the other reason I said 1 on each side. You can't square pieces. It doesn't work that way. I can't just take the amount of terms and put in that amount of squareds. If that was true, then I wouldn't have to balance any equations. You can only put 1 on each side. Okay, so this is the wrong way to do it, but someone's going to do it, so I like to show you that. Okay, step number 1. There's 2 of them.
Both kind of isolated. There's nothing changing.
Okay, well, what did I do way back in number 3 when it had a bunch of roots all over the place?
Slap them to one side.
I put them all on one side. I'm not going to do that here. Why?
Because you have nothing else.
Okay, well, that's okay. I can have one side equal to 0. That's okay. What's the reason I'm not going to move this one to join its friend?
Because they're not equal.
They're not the same radical. So if you peek back at number 3, they were both root x. So we could combine them all on one side. If I were to move this guy over, there's nothing I can do to add these. So what I'm going to do is just leave them isolated by themselves. Let's go to step 2. Square both sides. Brackets, 1 on each side. What happens on the left?
X minus 1.
What happens on the right?
2x plus 3.
Now what? Now I got x's all over the place.
Now move the x.
What? Why can I do it now and I didn't do it before?
Because they're not roots.
Because they're not roots. This is just a normal kind of linear equation. X is on one side, numbers on the other. How do I move a 2x to the left? So if I have minus 2x plus 1x, minus 2x plus x. And how am I going to move minus 1 to the other side? Add 1, so 1 plus 3. And then people panic at this spot, but x can't be negative. I know that. How do we get rid of it? X equals? Oh, but does it?
Let's find out. Maybe what assuming and actually try and figure it out on that guess.
This is the one slight little trick. Square root of negative 5, square root of negative 5. It looks like they're equal, except you can't square root a negative 5. So this is called does not exist or undefined. And even though this is does not exist or undefined, if something doesn't exist, can it be an answer? No. So still an extraneous root. So that's the only little trick if you get a square root of a negative. Even though they're the same, can't do it. It's impossible. How you feeling?